Hey everyone, and welcome. If you're looking to really wrap your head around the exact structure, the history, and the highly specific naming conventions of soil taxonomy, well, you have landed in the perfect place. Today we're going to map out the precise blueprint of how soils are classified in this explainer. It's almost like a giant linguistic puzzle, and we're going to put all the pieces together.
Here's the roadmap for our explainer today. We've got four main stops. First, we'll look at the defects in the old genetic classification. Second, we'll explore the new comprehensive system. Third, we'll dive into its features and advantages. And finally, the fourth part, we'll decode the detailed nomenclature of soil taxonomy.
All right, let's jump right into Section 1, Defects in Genetic Classification, specifically focusing on the 1951 U.S. decision.
Okay, let's set the scene. Back in 1951, a massive decision was made in the United States to develop an entirely new classification system. Why? Well, because the existing genetic system had some severe foundational flaws. For starters, categories like zonal, intrazonal, and azonal soils, they just weren't clearly defined. Plus, the whole classification was heavily based on assumed soil genesis, basically assuming how the soil formed, rather than relying on hard, concrete data. On top of that, the definitions for certain taxa relied exclusively on virgin soils, and when you got down to the lower categories, the definitions were incredibly subjective and comparative.
And honestly, the problems didn't stop there. The genetic system simply missed the mark by lacking suitable classes at several category levels. You had certain families that weren't clearly defined at all. There was way too much emphasis placed on just soil color. And to make matters even more confusing, the nomenclature, the naming system itself, was just this disjointed collection pulled from several completely different sources. It was kind of a mess.
Which brings us to Section 2, the new comprehensive system. Let's look at its chronological development.
Before we track the exact timeline of the historical solution that fixed these glaring defects, we definitely need to acknowledge the foundational figures in this science, exactly as noted in our source text. We have V.V. Dokuchiev, who lived from 1846 to 1903. He's widely recognized as the founder of modern pedology. And then there's C.F. Marbut, whose key era spanned 1920 to 1940. He's recognized as the founder of American pedology. So let's move forward and see how this new system builds over time. Spearheaded by Guy D. Smith, following that pivotal 1951 decision, a really rigorous series of approximations kicked off between 1953 and 1960. These drafts were actively circulated for criticism, for precision, and for revision. Each successive approximation got more precise, more complete, and was evaluated by more and more experts. Ultimately, this massive effort led to the seventh approximation, published in 1960. It was later supplemented and officially released as Soil Taxonomy by the USDA Soil Survey staff in 1975 as USDA Handbook No. 436. The system just kept evolving, leading to a second edition in 1999 and by 2010, the 11th edition of Keys to Soil Taxonomy.
Let's shift gears to Section 3, Features and Advantages. Basically, why this new system actually works.
The salient features that justify adopting this new taxonomy are seriously robust. Unlike that old, flawed system, this one is firmly based on measurable soil properties, taking into account all the properties that actually affect soil genesis. It uses a highly logical nomenclature that directly helps you figure out the place of the taxon. It is a truly multi-categorial system, featuring exactly 6 categories. And finally, it serves as a perfectly orderly scheme without prejudice, which makes remembering these classifications so much easier.
And the concrete advantages here? They are incredibly practical. See, this system classifies the soils themselves, rather than getting bogged down in soil-forming processes. It focuses entirely on soils, instead of leaning on related sciences like geology or climatology. And because of this is a real game changer. It allows us to classify soils even if their genesis is completely unknown. It creates a much greater uniformity of classification. Most importantly, soils that have a completely different genesis but share identical measurable properties, they are classified right into the exact same unit. Plus, you don't need any particular order for strictly hydromorphic and helomorphic soils like you did in the older systems.
All right, we've reached Section 4, the absolute climax of our explainer. Soil taxonomy nomenclature. We are going to decode this logical construction.
Now, the most unique feature of soil taxonomy is the unusual-sounding nomenclature used to identify different classes. I know, it sounds unfamiliar at first, but I promise you it has a highly logical construction.
These new words were actually coined from multiple root languages. We're talking Latin, Greek, English, German, and Japanese. The creators specifically designed these selected words to be self-explanatory, easily remembered, suggestive of the object's properties, short, and euphonic. That just means they sound pleasant and are easy to pronounce. Oh, and they were designed to fit into as many different languages as possible, globally.
So, the crucial point here is wrapping our heads around the rigid structure of this multi-categorical system. There are exactly 6 distinct categories, and they step down from the absolute broadest down to the most highly specific. We go order, suborder, great group, subgroup, family, and finally, series. Let's break down exactly how these names are built step by step. Starting at the very top, the first and highest category is the order. The names of the orders are coined words that all share a common ending, sol. That actually comes from the Latin word solum, meaning soil. These names are a combo of 2 parts, a word containing a formative element, and sol, connected by the vowel I for Latin words or O for Greek words. Some examples: mollisol, alphasol, ultasol, entasol, histosol, and spodosol. Now pay close attention to that formative element of the order, because it literally gets carried down into the names of the other lower categories as an ending.
And this brilliantly illustrates how the whole system clicks together. The second category, the suborder, consists of exactly 2 syllables. The first syllable suggests a specific property of that suborder, while the second syllable is that formative element from the parent order we literally just talked about. Take udal, crypt, or ustelf as examples. See how they seamlessly build right on top of the order classification?
Moving right along, the third category is the great group. The name of the great group is logically coined by prefixing one additional distinguishing word directly to the suborder name. This added prefix highlights a distinguishing character of the great group. Just look at the examples here: durasolf, hapludol, and calciester. It just stacks perfectly.
Next up, the fourth category is the subgroup. A subgroup name is pretty straightforward. It consists simply of the name of the great group, but modified by one or more adjectives. Because of this 2-part naming style, it's known as a binomial nomenclature. Really good examples of this include vertic haplostept and typic calciestert.
Down to the 5th category, we have the family. Now, family names are incredibly practical. They exist to meet the real-world need for making practical predictions for land use planning. So, they explicitly indicate the particle size class, the mineralogy class, and the STR class. Because it packs in all this vital data, it uses a polynomial nomenclature. A perfect example would be fine silty, cavolinitic, isohyperthermic, typic hapludol. That's definitely a mouthful, but it tells you exactly what you're working with.
And finally, we conclude our 6 categories with the series. Interestingly enough, the name of the soil series has absolutely 0 pedogenic significance. Instead, it represents a prominent geographic name, like a river, a town, an area, or even a person where the series was first recognized. Some examples of this are the Patanchuru series for red soils and the Kasareti-Pali series for black soils.
So, from its roots replacing a deeply defective system back in 1951 to becoming this incredibly robust 6-tier nomenclature, soil taxonomy truly is a masterclass in logical classification. But it does leave us with a really intriguing question to ponder today. If this carefully coined nomenclature successfully categorizes identical measurable properties regardless of a soil's underlying genesis, how might this multi-categorical system continue to evolve and adapt beyond its 11th edition of approximations? Think about that for a second. Anyway, thank you so much for exploring this explainer with me.